concluded. We just concluded measure of location. So we're moving on straight to measure of dispersion. Measure of dispersion. Measure of dispersion. So measure of dispersion. Dispersion, or what we call measure of spread. Spread. Or measure of variability. Variability. So that's the other part of that. So when we say measure of variability, there are 3 or 4 players here, which we have done before. Range, there's all called range. Range is always the highest number minus smallest. There's what we call mean deviation. Mean deviation. There's what we call variance, which we have done one time, but in a different way. There's what we also call standard deviation. So we're going to look at it when the data is on group and when the data is grouped to find variance, mean deviation, and so on. So we'll take the first question. So this one is to check how risky things are, how risky a project is, or how risky project evaluation is. But in this case, it's not finance, so we're just running calculation. We're not doing any interpretation here. So we'll move. Question 1. Are you there? Given.
Yes.
Given 1, 2, 3, 4, 5. Given 1, 2, 3, 4, 5. Full stop. Calculate the range. Calculate the range, R-A-N-G-E, range, comma, mean deviation, comma, variance, and standard deviation. Assuming they went further to say you should find coefficient of variance, you know how to do that one already. Coefficient of variance is standard deviation all over mean, so we're not going to that one. Already we have done that one somehow. So range, mean deviation, variance, and standard deviation. First of all, we'll find mean. Just like I told you the last time, we have actual mean, we have assumed mean. But this one, we are working based on actual mean. We'll also look at the one that involves assumed mean to find variance and so on. The first thing to do is to find mean, which is 1 plus 2 plus 3 plus 4 plus 5. Divide by 5. Result 15 over 5. Our mean, which is the actual mean here, is 3. Is it clear?
Yes.
So the next thing is range. Range has a formula, but you may not be seeing it regularly in this one we're solving. Range is highest number minus the smallest number. Highest number minus the smallest number. You have range. Range is the highest number or highest variable minus the lowest number. Highest here is 5, lowest is 1, The range is 4. For us to find mean deviation, we need to get a deviation. We need to get a modulus, or what we call absolute value of deviation. That absolute value of deviation is a way of removing the negative sign from the deviation. You are aware that a deviation will have a minus sign. So to remove the minus sign, we look for what we call absolute value of deviation or positive value of deviation or modulus of deviation. We go this way. We have just solved 2 now. 1, we have solved 1, mean. 2, we have solved range. We have solved range. And then 3, we want to look at mean deviation, which is empty. Mean deviation. Look at this as usual. Is our variable. This is 1, 2, 3, 4, and then 5. So we're looking at deviation. That deviation will be x minus x bar. Deviation. X minus x bar, that's the deviation. And that one is deviation from the actual mean. So our mean is 3. 1 minus 3 is minus 2. 2 minus 3 is minus 1. 3 minus 3 is 0. This is 1. This is 2. Because of the minus sign, we find what we call positive value of deviation. That is guiding it with 2 parallel lines for that deviation. So it means positive value of deviation, modulus of deviation, or the absolute value of deviation. In the simple language, we are removing the signs. That's what it means, those minus signs. Because if you don't remove that sign, everything will just be 0. Because minus 2 minus 1 is minus 3. That means minus 3 plus 3, that will be 0. So you remove the minus sign, and here will give us...
Did you square it, or you just remove the minus sign?
No, we don't square. Just remove the minus sign for mean deviation. I want to look for mean deviation. If it is a variance I'm doing, I will square, which I may want to do now, but I'm doing it separately so that you can understand before we start doing everything together. So here is positive value of deviation. So I've added all and I got 6. So in a simple language, MD, mean deviation, is summation of the positive value of deviation all over alphabet N. So it's going to be 6 all over 5. Now our mean deviation is 1.2. That's the answer to that question. Mean deviation. Deviation is attached to it. You must get a positive value. Because if I add this deviation alone, it will be 0, and that will not make any sense. So you remove the negative signs, and that becomes modulus. Is it clear?
Yes, sir.
The next thing now is to find variance and standard deviation. Variance and standard deviation. So, in that one, what I will now do, instead of removing the signs, I will square. Is when we're looking for variance or standard deviation, we square the deviation. So We'll move this way. Here's x, 1, 2, 3, 4, 5. So this is still our deviation that we did before. X minus S bar, as usual. This is t minus 2, minus 1, 0, 1, and then 2. Then we'll look for this square. Look for this square. This is 4, this is 1, this is 0, this is 1, this is 4. We add everything together, and that is 10. So variance, which is the sigma square as a symbol, is equal to summation of this square all over n. That will be 10 divided by 5. Result is 2. That is the variance. Remember, there's no frequency here. It's just a single set of number. That's why the formula looks very small. And when you are using an actual mean, the formula is always small. When it comes to assume mean, the formula looks a length, but we'll come back to that. But for now, this is the single set of numbers. And if you can still recollect, standard deviation is equal to the square root of variance, which means standard deviation is equal to the square root of 2. Square root of 2, and square root of 2 is 1.414. Agreed?
Yes.
Yes, so that is the solution to that problem. When you know variance, the square root of variance is standard deviation. When you square standard deviation, it will give you variance. So that is the solution to that small question. Is it clear?
Yes, it's clear.
Good. The next question is number 2. That was question 1. For number 2, that will involve some algebraic expression. Given question 2. Are you ready? Question 2. Can I go on?
Yes.
Question 2. Given A, alphabet A, comma, A plus 1, comma, alphabet A, comma, A plus 1, comma, A plus 2, full stop. Find the mean. Find A, question A, mean. B, mean deviation. C, variance. D, standard deviation. Find question A, mean. B, mean deviation. C, variance. D, standard deviation. The fact that this is alphabet doesn't mean that one cannot solve. You may see it in alphabet or just number like I've just done.
What do I do with it? Don't make it correct.
So, for more indication, question A, our mean x bar will be equal to A plus A plus 1 plus A plus 2. A plus A plus 1 plus A plus 2 all over 3. Because the variable there is 3. All those A is 3A plus 3 all over 3. Try to factorize 3 into A plus 1 all over 3. Our mean is equal to A plus 1. Is it clear? Are you there?
No, you cancelled the.
I can't see because it
Okay,
wasn't.
okay. All right.
That last one wasn't entering, so that's why I have to move it backwards. So there's no need for that one. So what you have is the 3 variables added together, divided by the total number, which is 3. The 3 A's will be 3A. 1 plus 2 is 3. Factorize. 3 is common. 3 into A plus 1 all over 3. So 3 shifts, cancel 3. And the mean is algebraic. A plus 1. So that's question A. Question B is to find the mean deviation the way we have been doing. We'll also find deviation. We have seen mean. We have seen the actual mean. Find the deviation. Find the modulus and get our mean deviation. When it comes to variance, we'll also find deviation. Deviation squared, and we'll get the result. But I'll run everything together now that you have no ideas. Can I clean?
Yes.
You have B, C, D. We can run everything together. I draw in a line. This is our variable. This is A plus 1. This is A plus 2. Deviation. Our mean is A plus 1. So A minus A plus 1 will give us minus 1. I hope you agree. A plus 1 minus A plus 1 is 0. A plus 2 minus A plus 1 should give us 1. So we'll get positive value of deviation, which is 1, 0, 1. Try to get another one. Deviation square, as it concerns our variance, is also 1, is also 0, is also 1. Because 1 square is still the same thing. Here is 2, here is also 2. So without wasting time, our MD, mean deviation, which is the C part of the question. No, that should be B part of the question. Mean deviation will be summation of positive value of deviation all over n. And here is 2 over 3. The next one is variance. V for variance. Variance will be summation of d square all over n.
Sorry, Mr. Vincent. Sorry to take you back because I just want to. This D
is deviation. D is deviation.
Did you give them number 1, 2, 3?
1, 2, 3. Yes, now those are A plus 1, A plus 2. There are 3 variables.
Okay.
Total number is 3.
So how do you get that minus 1?
Okay. This is A minus A plus 1. You know, because there's a minus, there will be bracket like this. So it will now come out as A minus 1. Abi?
Yes.
So A minus A is 0. We're left with minus 1.
Ah, they should not give this one in the exam.
They
should not even just try and give somebody this one in the exam. Alphabet.
You have to solve alphabet. Is it not part of maths? It's maths now. And that was why
Mr.
in that you have crossed that line. There is indices now.
Jesus.
But wait, in that you have crossed that line, there's indices.
Yes.
Now that means they expect you to do small subtraction and powers and so on, because that's exponent. So, but if it's alphabet like that, that's what just the same way we're doing ordinary number. So that's why we are, opening your eyes so that it will not be one-way traffic, so that you understand a little to the right, a little to the left. So that anyone that comes, you prepare and stop praying for they should not bring this stuff. Because and again, there could be objective, there could be theory. So some of these things could be an objective. And you're asked to find the mean, just like I got A plus 1. I should be able to arrive at that. So just understand it. That's what matters. So the same thing with the other one. A plus 2 minus A plus 1. So we need to put brackets. So that when we open the bracket, it will be A plus 2 minus A minus 1. So A minus A is 0. And 2 minus 1 is 1. That's how we got that. And that middle of A plus 1 are all the same. So A plus 1 minus A plus 1 is 0. That one is 0. So that is it. And I haven't found, what's it called? I haven't found variance as 2 over 3. The square root of 2 over 3 will give us root 2 over root 3. And that will become root 6 over 3. You remember sort?
Sorry. 2 divided by 3, 0.6. So square root of 0.
You can leave it as fraction, you can leave it as decimal, anyone you want. If you put it in decimal, no problem. You just find square root. Sometimes they want to leave it like that, objective. When it's theory, you decide on what you want to do. You can make it 2 over 3, which is 0 point something. When it's objective, they may decide to leave it as 2 over 3. And then find the square root of 2 over 3 and leave the answer in surd form. Surd form. Surd form simply means the square root attached to the result. For copies, I will show you that. We have seen mean deviation, then variance, that's the C. C is variance. B is mean deviation. So it happens that the two values are the same. It's not always like that.
Yes, you can change.
Good. Now we have something like this. That is our G. Standard deviation is the square root of variance. So even if the variance is in decimal, but like I said, they can decide to leave it like this. And we'll now move on. The square root of 2 all over the square root of 3. Agreed? If they want to leave it like this, so that will become root 2 over root 3. You rationalize it. That denominator you multiply by denominator, and the result will be the square root of 6. Okay, sorry. Okay, this is 3, square root of 6 all over 3. And this will be the answer. Maybe the question does not want it to be in decimal. I want us to leave it in short form. Remember, the question was root 2 by root 3. That denominator, use it to multiply itself and do the same thing to numerator. Root 2 times root 3 is root 6. And root 3 times root 3 is root 9. And the square root of 9 is the 3 as seen here. So the final answer for standard deviation is the square root of 6 followed by 3. So root 6 is a solve, because when you find the square root, you will run into decimal. That is how to calculate.
All right.
Good. Now, remember that if it's a group data, you already know, may not bother ourselves with that. If it's a group data, the normal theorem is to find mid-class, have you?
Yes.
And immediately you find mid-class, it becomes one single number and frequency, just like this one I'm about to solve now. So when it's group data, just find a mid-class and you start solving. But for now, we will just solve single one. So number 3 question for today, I believe. There is a, okay. Can I click?
Yes.
Okay. There is a question like this that I said one time, but probably this X, this F, 20, 25, 30, 35, 40, 45. This one will be 3. It hasn't changed. Here's 20. Here's 1, 1, 2, 3. So this one I want to find mean, mean deviation, variance, and standard. Find mean deviation, variance, and standard deviation. Is it clear?
Yes.
Good. Automatically, we calculated the mean yesterday, but we have to still show it. It goes like this. Our mean so this is frequency 20, 25, 30, 35, 40, 45. So this is 3, this is 5, this is 1, this is 2, this is 3. Find fx as usual. So 20 times 3 is 60, which we have done before. 25, 125. This one is 30. This is 35. This is 80. This is 135. You add up. We did this yesterday. So the addition hasn't changed. That's 15. So our mean is still summation of fx all over summation of f. And this is 465 all over 15. This is 31. So we already have our mean, so that we can find mean deviation, so that we can find variance, and then get standard deviation. Is it clear?
Yes.
Good. So I'm going to take another table, go do it once, and run the whole total. Go do the table once, put everything that we need inside, and begin to take them one after the other. Remember, the other one does not have frequency. That's why it was a length. But now, with this, we can have, so you have this X, this is our F, so this is 20, this is 25, this is 30, this is 35, this is 40, this is 45, this is 3, this is 5, this is 1, this is another 1, this is 2, this is 3. So we have, starting from first is deviation, which you know is X bar. We now have maybe D square. We now have positive value of deviation. We now have F D square. F D square. We now have the column, which is F positive value of deviation. Did you understand this table?
Yes.
Good. So that means that's how you do it if it's theory and examination, running like that, and get your results. So the first one, wow, our mean is 31. So 31 minus 20 is minus 11. 31 minus 25 is 20 minus 31, because that is the X. 20 minus 31 is minus 11. 25 minus 31 is minus 6. 30 minus 31 is minus 1. 35 minus 31 is 4. 40 minus 31 is 9. Then 45 minus 31 should be 14. Now we're looking for D square. D square is 11 square, 121, I believe. 6 square is 36. 1 square is still 1. 4 square is 16. 9 square is 81. Let me press calculator. 14 square. 14 times 14.
196.
Good. 196. So, assuming there was no frequency, we wouldn't have bothered so much. But because there is frequency, we're going to multiply frequency with D square, multiply with modulus. But let's get modulus. That means we don't want those minus again. We have 1, we have 4, we have 9, we have 14. So the next thing is to find F times D square. Our F is 3. 3 times minus 11 will give us minus 33. So F times D square. I had me multiply. 3 times 121. D square I hope that is 3, 6, 3. 3, 6, 3. Is it clear? 3,
Yes.
6, 3. Yes. So 5 times 36. What do you have? 5 times 36. Frequency times
180.
d squared. 180. Good. Then 1 times 1. That one is not a problem. It's 1. Then 1 times 16 is also 16. Then 81 times 2. What do you have? 81 times 2.
162.
Good. 196 times 3. 196 times 3.
588.
Yes. So let me add this column. That FG squared. What's the total? 363 plus 180 plus 1 plus 16 plus 162 plus 588.
1310.
1310. 1310. Then the next thing is the modulus 11. That 11 times 3. That will be 33. Then 6 times 5. I hope that one is 30. Then one whole number times 1 is still 1. Then 4 times 1 is also 4. Then 9 times 2, that should be 18. Then 14 times 3, that should be 42. So we add, what's the total now? 33 plus 30 plus 1 plus 4 plus 18, and then plus 44. 42. What do you have?
128.
128. Is it clear?
Yes.
So copy so that we can now solve B, C, and D with one table. Remember, look at the table very well. This is a table for just variance from actual mean. Variance from actual mean.
All right, you can clean.
Good. So I haven't seen the value. Our B is mean deviation. So mean deviation will be summation of F, positive value of deviation, all over summation of F. I hope that's one will go 128 all over 15. Divide, what do you have?
8.53.
8.5. Good, that one is gone. This one is summation of fd squared all over summation of f. And that's when we have 1310 all over 15. And what's the result?
$87.3.
87.3. Okay, point either 33 or 3, I mean.
Yes, 33333.
Good. Then the D part of the question is standard deviation equal to the square root of 87.33. Remember that standard deviation is the square root of variance, and our variance is 7.33. So the square root of that will give us
9.34.
9.35, Abby.
Yes.
Good. That's how to conclude that question. We have seen this frequency distribution, like I said. If it's a group data, the only thing you will do is that class, find the mid class. That the mid class will not be X, like this 20, 25, 30, 40, 45. So, which means the same thing we did here is what we are going to do for a group data. So just find the mid class, and then you resemble what we just did some few minutes ago. Is it clear?
Yes.
So that we don't waste time getting mid class again on this chapter. So, are you through with that?
Yes.
So we're going to move into another part of calculating variance. Just like I told you before, assume mean. What we did now was actual mean. And the formula does not look very simple. But when it comes to actual mean, assuming, the formula will look a little bit large. But that's how to calculate variance and standard deviation. So you can write calculation, another subheading on this measure of dispersion. Calculation of variance. Calculation of variance and standard deviation. Calculation of variance and standard deviation using assumed mean approach. Using assumed mean approach. Just to make the thing so easy, we're going to use that same figure we use of present, but I'll still dictate it so that you know. We're going to just use two examples. The first one we did, and the second one. If it's also a group data, you know, you find the midpoint in the resemble set. So calculation of variance and standard deviation using assumed mean. Question 1. Find the variance. Find the variance and standard deviation. Find the variance and standard deviation given the following set of numbers. Given the following set of numbers. 1, 2, 3, 4, 5. Given the following set of numbers. 1, 2, 3, 4, 5. Already the heading is very clear that we're using an assumed mean. We're using an assumed mean. We have our variable 1, 2, 3, 4, and then 5. We assume anything we like. Let's assume 2 that we assume one time. We now find deviation. Deviation from an assumed mean. We'll now use x minus a. A here is assuming, just like I told you, that deviation is of two types: deviation from actual mean and deviation from assuming. So this is assuming, as usual. 1 minus 2 is minus 1. 2 minus 2 is 0. And this 1, and this 2, and this 3. As we know, we're only looking for variance and standard deviation. So we'll just square. Just square. That's 1, 0, 1, 4, and then 9. You can add all this, very easy. This is 15, I suppose. And this one, the total number is 5, but the whole variables is 5. And that is how it should be. So from all indication, to answer the questions, variance will be we're also getting this one. We need this one also. This is the 5, I think.
Yes, that's d square over.
Yes.
Okay, over 5, 15 over 5.
Yes. It's still over 5, but that's not the 5 we're talking about. The 5 we're talking about is 1, 2, 3, 4, 5.
Yes, 5 variables.
But this is deviation. Deviation from assumed mean. And that is deviation square. So the formula will go like this. Summation of d square all over n minus summation of d all over n all raised to the power of 2. That's the formula. When you see the formula like this, it means it's from assuming. Assuming the formula is a little bit lengthy. That means if I want to do variance now, all I will just do is this same thing that is here. I won't change much. That d square, I will just put frequency in between summation and d square. That ordinary d inside, I will just put f. The formula is set. That our n will just be, which you know, summation of f, cancel. So, but this is a standard formula for variance from an assumed. Without wasting time, this first one give us 15 for up. Our n is also 15. Is it 15? Yes, 15. So the next one, oh, sorry, 5, Jerry. Total number is 5. I thought it's the other one. Minus summation of d is 5. All over 5. Everything raised to the power of 2. Result here is 3. 5 over 5 is 1. 1 square is 1. And the result is 2. You remember when we did it that time, we got 2, I mean?
Yeah.
So from all indication, standard deviation will now be the square root of 2, which is 1.414. And that is it. So, but if I want to use the formula, like I said, it's still the same thing I will write, but should I to be square roots. So it's either you are making this place, this my formula that is here, summation of d square over n minus summation of d over n all square. Just put square root on top, or you just put the square root of variance and get your result.
Mr. Vincent, this Zoom doesn't cut again.
It will soon be cutting from next class. I was only trying something.
Okay, you subscribed?
I subscribe just for some time because I can't work on that subscription because you people do not come when you want. You come when you want to come. So as a result, the thing will run.
Yes, good ways.
You not be economic. I just think I can try something. I want to record something. That's why.
All right, no problem.
By next class, it won't be like that. Is it clear now?
Yes.
Good. So with that now, the next thing is to find, well, I've done standard deviation. That's the end of question 1. Question 2, we are going to look at now. We're using that same number we used before, 20, 25, 30, 25, 40, 45. So we use it and also find variance. We'll do the same thing we just did here. But it's because the first one does not have frequency. That's why we will not see F in the form. Can I clean?
Yes.
Okay. So the second question, that's number 2 now. So this is number 2 question. Number 2 question is now 20, 25, 30, 35, 40, 45. If you look at the numbers here, 20, 25, 30, 31, 40. So in finding trying to assume, we can assume anything. Let me assume 40. Last time we did it, we assumed either 30 or what. Now I want to assume 40. We'll still get the same result. So we have deviation, S minus assuming. So we have this. So our assuming is 40. So 20 minus 40 is minus 20. And this one is minus 15. 40 minus 30 is minus 10. 35 minus 40 is minus 5. 40 minus 40 is 0. 45 minus 40 is ordinary 5. We'll get a column. We look for this square. This square here will be 400. There will be 225. 15, 15 is 225. 10 is 100. This is 25. This is 0. This is also 25. Is it clear? Remember, we'll find, hey, I've missed something there, but let's just put it here. You know, say there should have been frequency, Abby.
Yes, XF.
So the frequency would have been attached to the X before, well, it doesn't matter, but frequency will be attached to X before D and not but it doesn't matter. There is 3. I believe it's 3. Here is 5. There is 1. There's 1, 1, and 2, 3. So now we're going to look for F, D. We're also going to look for F, D squared. That's all we need. That time we did what is it called? We did ordinary D and we did D squared. The only difference is just that frequency. If there was no frequency, we would just be working with the D and D squared alone. But because there is frequency, we need to progress by using F to multiply D, by using F to multiply D squared, and that. So we'll try to multiply 3 times minus 20. That will be minus 60. 5 times minus 15. That will be minus 75. 1 times minus 10 is still minus 10. 1 times minus 5 is still minus 5. 2 times 0 is 0. 3 times 5 is 15. I need this total. The next thing is f times d squared. Our d squared is 400, first of all. 400 times 3, 1,200. 5 times 225. So it will be 1,125. Minus 10 times minus 10. No, sorry. 1 times minus 1 times 100. 125 should give us 25. 2 times 0, that is the f times d squared is also 0. Then 3 times this are 25, that should be 75. I hope you got that.
Yes.
So help me add now. Add FD. We need the column of FD. Add that of FD squared. And there's not the total.
Okay, minus 135. I'm not sure it's correct.
Minus
That FD, 135.
minus 135.
Yes.
It's correct. It's correct.
Oh, okay.
The fact that you got minus is not a problem.
Yeah, but when you add all those minus, it's minus 130. So
Are you sure?
yeah, minus 130 is not supposed to be plus 15.
No, you know, look at that one. There's a minus 10. There's minus 5. Minus 10 minus 5 is minus 15. Plus 15, then it's there, it's gone. So minus 60 plus minus 75 is minus 135. Is it clear?
Okay, yes.
So the last one, which is ordinary number, 121125. So
That is 2525.
2525. 2525. So copy it so that I can get the result there.
All right, thank you.
Okay. Now we have the variance is equal to summation of FD squared all over summation of this. Summation of FD all over something like this. All squared. So that is, you can see that the other one, there was no F. And you know that summation of F means N. So we just added F at the middle, added F to the D. The formula still remains what it was. In this case, we're having 2525 over the total number from that our distance is 15, Abby.
Yes.
3 plus 5 and so on. And this one is minus 135 over 15, all raised to the power of 2. So the result here 25 over 15. What do you have? 25 over 15. What do you have?
168.3.
168.3. Okay. Then this one, 135 divided by 15. What do you have? So whatsoever you get, you square it. Minus will go away.
9.
So just square what? What do you have?
9.
Square the 9. What do you have?
81.
81. So the results, subtract this, we'll have that same amount. What do you have?
87.3.
No, we have gotten this before. That confirms that our answer is in order.
Yeah.
Then standard deviation will now be the square root of summation of FD squared all over summation of F minus summation of FD all over summation of F all raised to power 2, which is the same thing as square root of variance. And you are aware that the square root is 87.33, which I still believe was 9 point something, I mean?
Yeah, 9.35.
So that's how to handle it. When there is an assumption, we do it like that. Is it clear?
Yes.
Let's just take a little. I will leave it like that. I'll just take something here that has formula. It will not do it for me, but it's similar to what we have done before. This is what we call interquartile range and semi-interquartile range. You know, you can calculate it with that cumulative frequency table, cumulative frequency curve or O'Keefe curve. Were you taught O'Keefe curve?
No.
So, but were you taught quantiles?
What do you call it? Sorry.
Quantiles, quarter. Q?
Yes. No.
Huh?
No.
Okay. Okay, you were not taught quantiles. You were not taught percentiles.
No.
Okay, no worries. That means
percentiles. Yes, I was taught percentiles.
so if you were taught percentile, that means you should also know quantiles.
Yeah, I probably know. Maybe it's just the name. I'm sure when we treat it too. It's
okay. So we'll treat it later, but let's just give you something else. We'll treat it later. But I want to detail this question. You try it for me. Continue some of that. Is it clear?
Yeah, sure.
So that we'll know whether you remember all these things. But that quantile and percentile, we'll look at it when we turn to this question again. Because the way you handle percentile is also how you handle quantile. So we're going to look at that one. So, but you will not plot any graph, Abi? No.
I'm sure we did all that one in secondary school, Mr.
So which means
because I was a science student. I did maths and I did further maths. So,
so that means you can understand that. But what we'll just do now is when we come next, we'll look at quantile and percentile. After that, I believe we can move to another topic. At least I don't think that's it again. So, but just take this one and go and try it as an assignment. All the assignment I give you, don't submit to. Oh yeah, no. Let's see whether you will submit this one.
I will submit.
Okay.
I've not finished that dividend share one. That's the only one I'm owing. But this one I will submit it.
Okay, no problem. So just take it. The average of a given set of numbers. The average of a given set of numbers. 1, 2, 3. The average of a given set of numbers. 1, 2, 3. A, B, A, B is 3. Is 3 whole number. And their standard deviation is root 2. The square root of 2 is root 2, comma. Find A and B. Find A and B. Find A and B. That's the question. So attempt it and then let me know about it. So we'll take a look at that quantile and percentage. And then
Okay.
for statistics. Then we'll look at the next option in that scheme of work.
Oh.
Any question?
No question. But this assignment, Mr. Vincent. This assignment 1, 2, 3, A, B. So we'll find A and B.
You know, you made a statement now that made me happy. You said you did further maths in school, have you?
Yes, so Mr. Vincent, years ago.
No
problem.
No, that knowledge,
No
it doesn't matter. It's not, we're not crucifying anybody, just attempt.
All right, okay. I'll try and bring it out.
On that note, bye for now. So we'll meet again. Okay, when you are ready.
Maybe on Thursday, but we'll talk about it. That one, at least we've done 2 classes this week, which is fine.